Who shares the screen? This is a lesson to start off from yesterday's lesson, which was about solving trig ratios. Again, when I see 1 over root 2, I know this is going to be the same as negative root 2 over 2 if I rationalize it. The first step here is we need to take the sine across, so it becomes sine inverse. Once you are up to this spot here, we need to draw out the unit circle because we need to find out what our base angle is. Okay, so what angle gives us root 2 on 2 for sine? We have our hand with our 5 fingers here. We want to do sine. And we want to count 2 fingers. So we count our pinky and our ring finger. This means we want this pi on 4 finger down. That there is our focus angle. Okay. Yes. Now we can see here that sine is negative here. So the quadrants that we're going to land in is T and C because T and C is negative for sine. And since our angle is pi on 4, we need to pivot pi on 4 from the pivot areas. Okay, so if we pivot diagonal by pi on 4, we can land on those spots there. And we can find our solutions from 0 to 2 pi if you like. Yeah, whatever you like. And you'll see here that you land on pi plus pi on 4, which is 5 pi on 4. And 2 pi minus pi on 4, that's 8 pi on 4 minus 1, which is 7 pi on 4. These, sorry? These are our 2 base solutions. So I'll write the smaller one first. That's 5 pi on 4. And I'll write the second one here, 7 pi on 4. But that's only 2 solutions out of an infinite amount. We haven't ended up with just theta by itself yet. So I'm just going to divide everything by 2. So dividing by 2 is the same as multiplying in the denominator. So these 2 solutions here are called our base solutions. And for us to reach our entire domain, we need to add on the period until we cap our domain. Now, an important thing was that we wanted our denominators to be same across the board, yeah? So there's a few things, pieces of information we need to find. We need to find the period, which is 2 pi on n. In this case here, n is 2. Okay, so n equals 2 there. So I have 2 pi on 2. However, I want to express it as something over 8. So I will rewrite that as 8 pi on 8. The other thing as well, I'll rewrite the domain instead of 0 to 2 pi. I'm going to rewrite that as 0 to 16 pi on 8. Because it's the equivalent. All right. Notice here that the denominators are all the same now. So it makes it easier for us to know when to stop. So we have our first solution here, which is 5 pi on 8, 7 pi on 8. If we decide to go backwards, we have to add or subtract our theta. Well, our period. If I want to find the next one back here, I would go from 7 pi on 8, and I would subtract the period. That brings us to negative pi on 8. So would we include that? Nope, because it's outside of the domain. So we're going to jump forward instead. This brings us to 13 pi and 8. And let's try and jump forward once more. We end up with 15 pi and 8. Do you reckon we should jump forward one more? 8 plus 13 is 21. Yeah, that's more than our domain. Correct. So our final solution stands here. Do we have to simplify anything? Can we simplify? No, we cannot. So that is, we leave our answers as so. Okay. So now we know how to solve for these. Hopefully you'll get a bit more time to practice. You'll have plenty of time to practice when we start sketching graphs. Okay. So at the end of last week, I've already introduced sine and cos graphs. Okay. Sine and cos graphs in 14G. So we're jumping back now. We're going to do 14G. And it's important for us to understand what the period is, what the amplitude is, what the maximal domain, and what the range is as well. Okay. There's a few features that I like to find out about the graph whenever you are presented with one. Now, I've drawn these two graphs here, and we've actually explored how this came to be using a unit circle. Remember we said, oh, for sine, we're measuring the y value. So what's the y value here? So on and so forth. Okay. Now, the basic shape of the graph can change, push and pull. This is transformations all over again. So this is another opportunity for you to have a look and see how transformations work. But now we're looking in the context of sine and cos graphs. So 14G here. So it says here, we want to state the amplitude and period for each of these. Now, I might go back up here to these graphs here. And I'll actually bring that note way back down to the bottom. So it's our latest set of notes. So this is our basic graph for sine and cos. Okay. We can rewrite this like so. If we want to include transformations, A equals sine, of n theta minus h plus k. So notice how I didn't use x there. Instead of x minus h, we can use theta minus h. However, if they do want to put as the x and the y axis, they can write it like so. We can identify all these features, yes? All right. Same thing with cos. Except with cos, the only difference is that it's not sine, it's cos instead. You see, the ingredients stay the same. It's just the function changes. Okay. So one is sine, one is cos, but the structure stays the same. Now, this A here, we still know as the dilation from the x-axis. So if we dilate from the x-axis, it'll just go like this, right? Or it might go a bit closer. All right, that's the effect of the A there. The N here is the dilation from the y-axis. So we might go longer, or we might actually squish ourselves. So you can see that there's actually two periods between 0 and 2 pi. Now, this here is what I call a period or a cycle. Okay, because it goes from start to finish. As soon as I get up to here and I continue, notice I'm actually continuing, I'm repeating the pattern. Okay, so it's important for us to identify how many repeated cycles we have and how how long it takes for us to finish one cycle. Okay, so I'll label this in this color here. From here to here, that's one period or a cycle. And the way we calculate that is 2 pi over n. Now you might wonder, where did this 2 pi on n come from?
Yes.
You wonder? Good. Essentially what it is it's our dilation from the y-axis. We know that the standard period is 2 pi, right? When we dilate, this is a dilation from the y-axis by how much? Is it n?
What is this?
For the dilation from the y-axis, do we just read that as n? Wasn't it
A.
reciprocated? A is A, right? You read A as like dx times A, right?
Yeah.
But when it comes to dilation from the y-axis, we must reciprocate that value. Yeah? I'll go back to the basics here. Remember that this is the image, yes? The image is equal to, this is the image. So x was equal to n times x minus h, and it's x dash, yeah, because it's the image equation, right? This here is the image compared to the original. So if I want to relocate and see what happens to the original x value, I need to rearrange to make x dash the subject. And you can see here that it's 1 over n times x. This is from chapter 7. Okay. If you were to read it directly off the equation, you see it like so. So for this, I've already explained this ages ago, but it's dilation of 1 over n. When it's the y-axis, you need to flip the n value. So if we dilate it by a factor of 1 over n, we take our original period, which is 2 pi, yeah? And we have to multiply it by 1 over n. Isn't that just 2 pi over n? And that's how we get it. That's how we get it. So if you just want to remember the period, there's two things that you have to remember from this exercise for 14G. Your amplitude, which is A, and your period, which is 2 pi on n. That's all. Okay? So if we have a look at each of these here, we just simply need to state the amplitude and the period. Simple, straightforward. So the amplitude here is 2. It's just that A value. The period here, however, is 2 pi over n. What's our n value here? 3. So our period is 2 pi over 3. What does this mean? This means that if I was to sketch up the graph for sine, goes up, down, and back up. Instead of it going from -1 to 1, what's the amplitude do? Yes, that's correct. Start from the lowest number, -2 up to 2. And instead of 0 to 2 pi, right, what's it stopping at? 0 to 2 pi over 3, correct. Whoops. Does that make sense? Now there's a few lines here that I like to also add in. I like to call this here the minimum line. This line up here, the maximum line. And you notice that there's always a point where it's like in equilibrium, right? I like to call that the mean line. Yes. Yep.
That's basically how high.
That's correct. How high it fluctuates. That's correct. It's how long something is. Ben? That's pretty much it. So instead of just answering this question by just simply stating the amplitude and the period, I'd like you to actually draw out one cycle, just so you can see. Okay? Ben? Mm-hmm. Now, what's a negative do? It flips it, correct. So that's a reflection in the x-axis, correct. So write down your information first, and then we'll look at drawing it up so we can make a visual, okay? I'm gonna write this down. So your amplitude here is always positive, yeah? It's always positive. Just remember that the negative there is just a reflection in the the x-axis. Sorry, the x-axis. Reflection in the x-axis. So amplitude here is 1/2 in this case. What's your n value? It's 1/2, correct. So that's your A equals 2, n equals 3, A equals 1/2. A also equals, sorry, n here is also 1/2, right? Because it's 1/2, like so. So how do we calculate our period? 2 pi over n. That's 2 pi divided by, which equals to 4 pi. So here's our graph. Here we're going T and F of T. Do I go up, then down, then back up again? We have to reflect it, correct. So we're actually going down and then back up, then down again. Whoops, sorry. I should have marked it like this. Start, end, break it in the middle. 1 section, 2 sections. That's break it up and you draw it more easily and more consistently. What's the start and the end? 0, 4 pi. Now, you notice here that there's actually a 4-way split. 1, 2, 3, 4. Oh, sorry. 1, 2, 3, 4 parts, yeah? So let's label in the other bits as well. Should we also label the amplitude as well? What's our minimum? -1/2, correct. What's our mean? 0. When would the mean change? Your translation? Where? On the y-axis, so vertical translation, right? That will bring the mean value up. Right now, you can see the mean is just at 0. Okay, what's this point here? 2 pi, correct. Split it in half again. Pi, and then multiply it by 3. 3 pi. Does that make sense? So I want to see that 4-way split, that segment. So if I was to go back to the first one here, what would halfway be? If I multiply this by 1/2. Sorry? 2 pi over 6, which is pi over 3. What's here? Multiply this by half. Pi over 6. Right? And then what's the 3/4 way? Multiply by 3, which is 3 pi on 6, which is pi over 2, yeah? Does that make sense? I want you to learn how to segment this because this becomes really important. So start and end, break it in half again, and then multiply by 3 to get this third piece. Because it's like 1/4, 2/4, 3/4, 4/4. Now this looks wacky, right? This looks really weird because I've got really random numbers. I've got pi on 6, I've got pi on 2, and then I've got 2 pi on 3. Like, how did we get those numbers? How is it consistent? We can make them all the same denominator, right? Let's try that. What's the best denominator for us to make it all common?
6.
Pi on 6. Okay, so here's pi on 6. We've got 0. What's this one here? 3 pi on 6. Oh, is it? Sorry. Yeah, so can you see why when we do solutions, we don't simplify it until the end? Leave it so it's a common denominator. We did this yesterday. Remember how I didn't simplify it, so we kept it the same denominator? That's why it's useful to us. Whereas if you're looking at this, you're like, which one's bigger, which one's smaller? Okay, you'll pick up on these nuances once you start to do it. Okay. Can you do it for the third one, please? Write it down, label it. Label what your A is, what your N is. What's your N in this case?
3 pi.
3 pi. T. T. Notice what I'm going to do here. I'm going to go 1, 2, break it in half. And now into quarters. What's our amplitude or what's our range? -4 to 4. Do we start at the bottom here? Where do we start for cos? Yep. Water slide. Whee! And then we go back up again. 1, 2, 3. Okay. See if you can label these sections now and segment them halfway again, and then multiply by 3. Yeah, because have a look. What happened to the pies for our period? They cancelled out, correct. So we're actually left with the fraction. There's no pi on it. Sorry. Okay. I'll label it here, yeah? Step 1, step 2, step 3, step 4. Number 1 is just having 2/3, right? Step number 2 is that we half it. So we multiply that by a half. This becomes 2/6. Notice I didn't bother simplifying it yet. Step number 3 is if we half number 2 again. Sorry. You could do 1/3, yeah. That's fine. You can see that. So I go 2/6 and then I multiply that by a half again. I don't bother simplifying it. And then I can multiply this last one. This is notice this one is our smallest increment now. It's almost like your base increment, yeah? And then you can multiply this by 3. You can multiply it by as much as you want. This is our singular increment. Yeah? Does that make sense? So it's like finding, it's equivalent to finding, okay, how much is pi on 6 worth? If I know what pi on 6 worth is, then I can multiply that 1 pi on 6 by as many sections as I need to. True? So this is like understanding fractions again and how it works. Now you can actually see another like. Oh boy. What's that? What? Do what? Simplify? Yeah, I'll simplify it there. Yeah, you can just simplify it as you go. You can simplify it as you go. Yeah? Yeah, it should be easy. What's our minimum? -4. What's our maximum? What's our mean? 0. Zero. So I want you to understand here that you will be able to sketch the graph if you know what one cycle looks like. Because if you know what one cycle looks like now, you can just rinse, repeat, copy and paste. 14G. Got 2 questions here. Please write these down. What do we like to know about these 2 graphs? Yep, there's a reflection in the x-axis, okay. What's our amplitude? So get used to writing the amplitude and the period now, yeah? Amplitude is? 2. Period is? 2 pi over n, which is 2 pi over a half. So 4 pi. What's our domain for the graph that we need to sketch?
0.
So how many cycles do we need? How many periods do we need to sketch?
2.
How much is 1 period worth?
What?
How much is 1 period worth? So how many of these 4 pi's fit in between here?
1.
Just 1, okay.
Why are we learning this thing?
Why are we learning this? Because once you get to problem solving, we can start applying this. it can apply in different situations. Say, for example, the level of water in the ocean. It doesn't just sit there all the time. It changes, the tide changes throughout the day, right? So you can see this fluctuation. Now all you can see is it going up and down, right? Up and down, up and down. But then if I add an axis of time to it, it drags out now. So it's no longer going up and down. It's actually going up and down, up and down. Does that make sense? And we can map that using a sine or a cos graph. Sorry? Sine waves? Yeah, absolutely. So sine waves is in physics. What? Sound waves? Yeah, absolutely. So sound waves work the same way. If you flick the string of a guitar or even musical instruments, radiation, absolutely. Sound waves. Right? Applications. Have a look. The electromagnetic spectrum. So that follows sinusoidal or cosine waves. Okay. Yes. So this is why we learn it. Okay, so that you can understand earthquakes, vibrations, sine waves, seismic graphs, sine waves. Question? So we got a negative sine graph. We go 1, 2.
Seriously.
Seriously? You want that in the recording? Always. Wow. Whoa. Did we just sketch the graph? We did. These. Is it really warm in here? Yeah. Does anyone want some fresh air?
That one. They're better than me.
Aircon. Now the air purifier will give us fresh air. Air fryer. Did I say air fryer? Fryer? Oh my goodness. Everything's going wrong. Amplitude. Wahed. 1. Period. 2 pi over n, which is 2 pi over 2, which is pi. So how many cycles are we going to draw between 0 and 4 pi? 4 of them, yeah? Oh, yeah, we're serious. Now, notice here, your axes are y and x. Now, be careful here. Careful how we segment it, yeah? What's our amplitude? 1, yeah? We're going to go -1 to 1. I'm going to start here at 0 and end at 4 pi. Cool. How should we split this line? Halfway? So that's 2 pi. Again? 1.
Then 3 pi.
And then 3 pi. Okay, cool. Yeah, we're going to chop it up now, yeah? Because we know that between, how long's our period? Pi. So between 0 and pi, technically we need to fit in a negative cos graph. What does a negative cos graph look like? We know that this is a positive graph. Starts from the bottom. That's correct. So you see this line from 0 to pi, right? I'm actually going to make these increments now. And this is how you can do it. I'm going to make these thicker. And then between these thick lines, I'm going to split it into 4. So halfway and then smaller increments. Can you see how like the variations in the lines? Then I'm actually just going to dot them. I'm going to dot them. 1, 2, 3, and 4, and 5. So you've left something here. Yeah, you can go look for it, mate. If there's no green book in here, then it's gone. But knowing our school, no one steals books, man. That's a shame. Check at the front there. Is that it? Ah, that's a shame. Good luck, man. I know, right? And notice here, when I sketch it out now, 1, 2, 3, 4.
I'm so pretty.
Wow. Okay, again, we need to do another cycle. So we're going to split it up. What's that? Yes, we will. And this is where it starts to get interesting, right? So make sure you focus on sketching the graph out nicely first, and then we can focus on labeling the graph, yeah? Do it, do it, do it, do it. You know, have you started to notice a pattern now? What are some features that we need to label on here? What are some features that we need to label? We need to label some points, yeah? What are they? Yeah, go. A max and min? Okay, sure. So min, max. What else would you label? Intercepts, correct. So when I say intercepts, it's X or Y, yeah? What else? Should I label this one? Thank you, endpoints. Coordinates, yes. By the way, this one here is optional for max and min, yeah? I'm going to put that one last. The main ones we care about are intercepts and endpoints. Okay, so how do I actually know what this one is? Well, we can label these ones first. Let's label the endpoints. We've got 0, -1. Over here, we've got over on the right. Excellent. I'm gonna go with the shorter one now. How do I know what this is? Here's half of pi, yeah, and then halfway of that again is pi over 4. Good. So pi over 4, comma 0. 1 pi and 4, 2 pi and 4, 3 pi and 4. 3 pi and 4. Yeah. The less time you spend complaining, the more time you get to write it, yeah? What's here? Instead of saying pi, what are we counting by? 4 pi and 4. So what's this one? What's the next one? Yeah. But what's the next intercept? 7 pi and 4. Correct. 8 pi and 4 is the same as 2 pi. Continue along. 9 pi and 4. And then 11 pi and 4 is just this one here. 12 pi and 4 is the same. Correct. 14 pi and 4 and what's 16 pi and 4 equal to? 4 pi. Right. Wow. That's it. So if I was to draw the minimum line in, you can see here, it cuts through the maximum line and then the mean line. Right? Those are visual aids for us. I like to call them guidelines, okay? Now you can see here, it's wonky. It's terrible, right? So how can we make this more accurate? If you have line graphs or if you have grids, yeah? Now, can we take this to the next level? Should we take this to the next level? Because notice we've only dealt with dilation and reflection. We've only dealt with dilation and reflection, yeah? Dilation from the X, dilation from the Y, and reflection in the X, flipping up and down. Are you ready? If you're not, you're going to be ready. I'm going to throw you directly into the deep end.
God help me, like this thing.
Actually, I won't.
Ayun.
49. Because 14H was solving trigonometric equations.
Can you show me the last one?
Sorry?
Never mind.
14A. And this is in the form of y equals a sine or cos, right? X minus h, but we're not going to have the plus k. There's no vertical translation, okay? As you notice here, there's no +1. So what does that mean about our mean line? It's 0, it hasn't moved up or down. So we're still fluctuating about the x-axis or the horizontal axis, okay? Let's see if we can draw one complete cycle here. And it also says the greatest and least values of y. What is this referring to? Yep, minimum and maximum values. Let's give this a try, shall we? Third warning. No. Now, you see me draw it rough. I'll make it perfect now so you can see. What's our horizontal axis? X? Theta. Theta. What is our amplitude? 3. Now check this out. I'm actually going to use guidelines this time. One line at the bottom, one line at the top, and one line in the middle. Okay. Just one cycle, yeah? So we know our amplitude is 3. What's our period? 2 pi over n. What's our n value here? 1. 2 pi over 1. Why? Hey, 1. What? Why 1?
That thing. Okay.
Yeah. N equals 1. So we got 2 pi, yeah? Yeah, so that's the question, right? What does the pi minus pi on 2 actually mean? Translation in the x-axis.
Yeah.
Is this the x-axis though? The theta axis. How about we just generalize it and call it the vertical? Horizontal. Horizontal or vertical? Horizontal. The horizon, yeah? And how do we find out how it's shifted? We let the bracket equal to 0. So what does this mean? It's moved pi on 2 to the right. Pi on 2 to the right. Now, this is where I encourage you to use your pencil, if you have one.
Taken by.
Sorry, what? I don't know what you're talking about. Now, typically, right, our sine graph would look like this. One. Let's just make it 2 pi here, yeah? 2, 3, 3, 4. Typically, our sine graph would look like this, yeah? Because it hasn't been reflected. It's not flipped. No negative. Our amplitude is 3, so we're happy about that. Right? So usually this would be from 0 to 2 pi here. What's this one here? 3 pi on 2, yeah? But we need to shift everything pi on 2 to the right. So where's this first point going? To pi on 2. So our actual graph now starts here. Does this make sense as to why you would want to draw the cycle there first and then you shift it afterwards? So where's our maximum going to be at? It was originally at pi on 2. Where's our maximum going to be now? At pi. Yeah, so it's shifted across by pi on 2. Yes. So where's this particular point going to move to? 3 pi on 2, yeah? Because notice we're moving pi on 2 to the right. Where's our minimum going to be? Where's our minimum? 2 pi. And where's that end point going to move? Where's 2 pi going to move to? Yep, this point here goes over here, right? 1. How'd you get 5 pi over 2? Yep. Or you can count 0, 1 pi on 2, 2 pi on 2, 3 pi on 2, 4 pi on 2, 5 pi on 2. Yes. If I remove all that and I remove all these, you end up with a clean graph. There's your graph. Sorry? I'll keep all the guidelines there. What else do we have to label in?
Intersect and.
Yep. You can label them as coordinates if you like. 3 pi on 2, 0, 5 pi on 2. So notice we're not trying to build everything at once. We build things layer by layer, yeah? You never build a house starting with the roof, yeah? Yeah, you got to start with the foundation first. So that's why you start with the base graph. Does that make sense? And then you add on, you translate, you manipulate it. Be a builder. Bob the Builder. Bob the Builder. Yes, we can.
You watch those things?
Bro, I grew up with that, man. Bananas in pajamas are coming down the stairs. There's a bear in bed and a chair as well. Open wide, come inside. It's Hume Central. Yikes. Would you like to try this? Yes? Sorry? Which N? The N? Isn't that your N? Yes? The N is directly next to your variable on the inside of the bracket. Was there N? An invisible 1. 1,000 years later. The theta or whatever your variable is there. It could be a t, it could be an x. Yeah. Theta. Yeah. What do you mean solve for theta? Yeah. So if you want to find your horizontal translation, if it's moving left or right, is it moving left or right here? If you're unsure, let the bracket equal to 0. Okay. So I'm going to do that. I'm going to go 2 bracket theta plus pi equals 0. If I divide everything by 2, it's still, that disappears, yeah? And then theta equals to negative pi. So what does that mean? Yes, we're translating to the left by pi. Okay. What's our amplitude? So are we ready to sketch it? Yes and no? Okay. If you're not ready, just do it anyway. Now, since I'm moving to the left, I want my axis to be a bit further to the right so I can have room to move it over, yeah? That's correct. So the n here is going to be used for the period. The period is 2 pi over 2. 2 pi on n, which is equal to 2 pi over 2, which is equal to pi. So our sine graph here is going to go from 0 to pi. So I'm going to go 1, 2, 3, 4. That's going to be pi right there. We go up to 1 and we go down to -1. This is a sine graph. So we go 1, 2, 3, 4. That's what our base graph looks like. However, we move this graph now, right? This is 0. This is pi here. This is pi on 2. We're going to move this graph now pi to the left. So immediately I know that 0 is going to go all the way down to -pi. Blame everyone.
You are first.
Alright, so if this 0 moves all the way over here, that's our first point. Now we're just translating. You can see we're just moving the points. This pi on 2 moves to negative pi on 2. This minimum here moves to negative pi on 4. The idea here is to understand the patterns that come to be. 1, 2, 3, 4. Wow. That is all. It is perfection. How are we feeling? Does this make sense? Sorry? Wait. Which one? The left side here? How did I get which bit? Negative pi and 4, negative 3 pi and 4. Segment again. 1, negative 1, negative a half pi, negative 1/4 pi, and then multiply that by 3. You can't possibly understand this until you sit down with it, you focus and you play around with it. So you must do questions. Must. M-U-S-T. Don't even think about the other half of the word. If the period was 2 pi, so what would that mean about n? What would n equal to? If you want your period, okay, here's a puzzle. If you want your period to equal to 2 pi, what would n be? 1? Work backwards. Because you know your period is equal to 2 pi over n, yeah? Take this.
It's 1.
Equate it with this. Right? Because that's your period equals your period, right? And you just find out what n is.
Yeah.
So, okay, I'll ask you another question. If my period, this is just a puzzle, yeah? If my period is 24, like 24 hours, and my graph was a sine, what would my n value be? Don't stare at it. Write some calculations out. What do we know about pi? What do we know about the period? How do we calculate the period? 2 pi over n. Now you can see this is pp, yeah? P equals p. So we can equate those quantities, can't we? Yeah, so I can equate 24 and 2 pi over n. How do we solve for this?
So if n on the book, then I'm going to have half the one's time, so 24 pounds, you have to be divided.
Buster rhymes. By 24, yes. So n equals 2 pi over 12. Wow. That's a cool question.
Yeah.
I'll delete it. I'll leave it. Okay, cool. All right. You have a question? Not yet. Do you want me to put the notes page by page, or do you want me to upload the entire PDF?
Like the whole thing.
The whole thing? The whole thing. Okay, and then, sorry? Yeah, I didn't put last night's one on. I mean, yesterday's one on last night. That's it. No more videos.